Welcome back to Algebra 2. We haven't had a video in a little bit, so it's good to be back. Today we're going to be starting a new section, Chapter 7 specifically, and we're going to be talking about rational expressions and equations. So remember when we talked about rational exponents, what I said was rational is just a fancy term for fraction. And it's the same thing here. We're going to just be talking about fraction expressions. So here's an example of a rational expression. X squared plus 2 divided by 3x. This is a rational expression. We have variables and it's in fraction form. Pretty simple, right? So we're going to be learning today first how to simplify, but we're also going to be learning how to multiply, divide, add, subtract, and solve equations. So that'll kind of give you the next few days of what our notes are going to be about. They're all going to be, everything is going to be about rational expressions. So hang tight with me. We'll take some notes today about simplifying, and then we'll be good to go for the rest of our chapter. So we're in chapter 7. Today's just our introduction. We're going to be reviewing some things like factoring and solving through factoring. But let's start with some tips to remember. Tips to remember when simplifying rational expressions. And I'm going to tell you this 3 times. Factor, factor, factor. Those are your 3 tips. You can put exclamation points on them. You may have to factor multiple times before you begin to cancel anything out or before you get to simplify things. But that's our key word here. So we're going to review our factoring, refresh your factoring memory. So when I factor, I'm going to look at each term and determine what my least common multiple is. So it's called our LCM, right? Least common multiple. What is the smallest, or not our least common multiple? No, greatest common factor. Greatest common factor. What's our greatest common factor that goes into all of these numbers? Let me get my acronyms correct here. So in 2r minus 4, what's my greatest common factor that goes into 2 and 4? It is 2. So I'm going to factor out like dividing by 2, right? That's what that means, the opposite of distribution. So I'm going to pull out that 2. So when I divide by 2, I get an r minus 2, right? Let's look at this one. This one's a trinomial, so it's going to be a little bit different. It's the opposite of FOILing. So remember, we're going to multiply to get 2 numbers that multiply to get that last one and add to get our middle term. So what multiplies to get -6 and adds to get a +5? Well, one of them has to be positive and one of them has to be negative. I know that, right? And it's going to be 6 and 1. Yeah, 6 and 1. So reviewing factoring here, if I just have 2 terms like a binomial here, I'm going to look for my greatest common factor. Again, it's 3, so I'm going to pull out a 3 here. It's like dividing, so thinking about dividing by 3, get a 5a minus 1. Remember when you divide here, just like up here, you don't get nothing, right? It's not 0, it's 1. So anytime you divide a number by itself, it is 1. All right, let's look here. We're going to do 2 things here. First, I want to see if I can find the greatest common factor, which I can. It's 2 and v. So like I'm dividing out of 2 and a v, 2v, I can pull out this. So I have a v squared minus 12v plus 32. So remember when I said factor, factor, factor? Let's see if we can keep going. We probably can. So let's see, 2v, what multiplies to get 32 and adds to get -12? It looks like my signs are going to be the same here because I'm multiplying to get a positive, but I'm adding to get a negative. So they're going to be the same and they're both going to be negative. I'm going to say it's 8 and 4. All right, can I factor anymore? I think I'm done. So this is our key thing here. We want to factor. All right, let's look at E. We're going to solve equations. So remember, solving equations, we want to think about our zero product property. That means that I can set either one equal to 0 and it will equal 0, right? Because if I multiply something by 0, it all equals 0. All right, so first we're going to factor. So I want to know what multiplies to get a -6 and adds to get a 5. Oh my goodness, look at that. It's the same as up here. So we're just going to copy that up there because we already have the answer. Equals 0. Here's my zero product property. X plus 6 equals 0 and x minus 1 equals 0. So solving for x, we get x equals -6 and x equals 1. This is going to help us in a little bit determine what our domain is. So I'm going to write this. This determines domain of rational functions. And we'll talk about that in a little bit. All right, let's keep going. Let's see. Let's factor this here. S squared minus s minus 2 equals 0. So let's see what multiplies to get a -2 and adds to get a -1. I'm going to guess it's 2 and 1. I'm going to say it's -2 and +1. Y'all are like, these are too easy. It's going to get harder, I promise. All right, so zero product property says s minus 2 could equal 0 and s plus 1 could equal 0 for this to equal 0 here, because if I multiply either one of them by 0, I get 0. So I get s equals +2 and s equals -1. There we go. All right, so later on we're going to have to plug these in and really see if they are actual zeros or what. But it'll determine our domain. This doesn't equal 0 here. Go ahead and put a 0 there. All right, you get to do letter G, and we're going to move on to simplifying, okay? So when we simplify, remember factor, 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 and then we can reduce. So I want to look at here. If I have 32y squared divided by 12y, we're going to do exactly like what we did last chapter and simplify. So we can subtract our exponents here. So I have a y in the numerator, and I can deal with my numbers here. If I divide by 2, what do I get? A 16 over 6. And I can keep going, right? 8 over 3. I think that's as far as I can go. All right, so that's your simplified form. Let's move over to J, a little bit different. I have a binomial here, so I can't do what I did here. I'm going to have to see if I can factor first. So let's see if we can factor. Greatest common factor of 6 and 3 is 3. Greatest common factor of y squared and y cubed is y squared. So my numerator looks like this. 2 plus y divided by 3y squared. Oh, well, that's lovely. Look at that. Anything over itself is 1. Because it's being multiplied by the 2y, I can go ahead and cancel those out. So my answer here, or my simplified form here, is just 2 plus y. All right. Let's move down to letter K. We'll do that one really quickly because there's an extended factoring here. So letter K, I'm going to see if I have a greatest common factor first. And I do, it's x. So I have x times x minus 7 divided by, well, this is a trinomial. They don't have a common factor here, but I'm going to see if I can factor this way. So what multiplies to get positive 49 and adds to get a -14? It is -7 and -7. Ah, this is great because this binomial matches this binomial. The whole binomial has to match, okay? So keep that in mind. So I can cancel it out. It doesn't, I don't have 2 on the top, so I can only cancel 1 out. So our simplified form is x divided by x minus 7. That'll be your answer. All right, let's move on. Flip it to the back here. Let's look at letter L. I have 2y squared plus 13y plus 20. I don't know if you can see that. Zoom in just a bit, maybe. Let's write it out on our whiteboard. That might help. If you're looking at it, our first question is, can I factor out a GCF, the greatest common factor? And I think our answer in the numerator at least is going to be no. 2y squared plus 13y plus 20 divided by 2y squared plus 17y plus 30. All right, depending on how you learn to factor might help here. I like to multiply A and C and then split the middle term. It's up to you though. Come on. You can do it. There we go, clearing up for us. I like to multiply 2 times 20 here, my A and C, that gives me 40, and split the middle term. So I want to know what multiplies to get 40 and adds to get 13. 13, that'll help me. Okay, so if you don't like to do it that way, you can go ahead and go about your own way. I like to split the middle term because it gives me the right answer every time. I don't have to keep guessing and checking. So I want to know what multiplies to get 40, adds to get 13. I'm going to say 8 and 5. So I'm going to split my middle term into 8 and 5. So this, now I'm going to factor by grouping. So I'm going to keep this as my numerator, 2y squared plus 17y plus 30. It doesn't get hard, it just gets a little bit busy, right? So I'm going to factor out what I can from the first two. 2y, and now I have a y plus 4 in the back. Now I can factor out a positive 5 here, and I get a y plus 4. So my factored form is 2y plus 5. Make sure you can see that, and a y plus 4. All right, that's my factored form for my numerator. All right, let's go back and do our denominator now. Notice how I left it so I could do it as steps. All right, so we're going to multiply A and C. 2 times 30 is 60. And then I'm going to see, oops, sorry, I'm going to split my middle term. So something that multiplies to get 60 adds to get 17. That's going to be my split of middle term. So I have a 2y squared. I'm going to say it's 12 and 5, right? That makes the most sense. 12y plus 5y plus 30. All right, factor by grouping. So I'm going to group the first two, group the last two. See how easy this is? What can I pull out here? I can pull out a 2y. This is looking pretty good. y plus 6. I can pull out a 5 here, and that's going to be a y plus 6 again. So down here, my factored form, 2y plus 5, take my first two, and then I have a y plus 6. All right, so factor, 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 right? Always be factoring. It looks like I'm going to match my binomials here, and I can cancel those out. So my simplified form is y plus 4 divided by y plus 6 is my answer there, okay? It took a little bit more space than I gave you here, but we write small maybe. I can't write small. I write large. Anyway, all right, moving on. So I'll let you do letter M. This one was y plus 4 divided by y plus 6. Make sure you fill in your work for that one. All right, so let's move on to finding a domain. We talked about doing that just a second ago. When finding a domain, remember that a 0 in the denominator of a function always results in an undefined function. So if I have an x value that results in a 0 in the denominator, then it's going to be my asymptote, or it's going to be a whole. And we'll continue to talk about that. So to find the domain of a rational function, set the denominator equal to 0 before simplifying. So we want to see what before we simplify this, we want to see what our domain values are, okay? So I'm going to say x squared minus 25 equals 0. So now I'm going to factor, right? X minus 5, hey, conjugates, look at that. x minus 5 equals 0, x plus 5 equals 0 using our zero product property. So x equals 5 and x equals negative 5. So you can see going to our graph here that I've plotted for us, get my little straight edge, that at negative 5 and 5, we have what we call an asymptote. So I'm going to just kind of draw that line for us. An asymptote is like a boundary line for your line. It's never going to touch these. It's going to get closer and closer, but it's not going to touch this vertical line. So I'll tell you, we have an asymptote at x equals 5 and x equals negative 5. Those are called asymptotes. Weird word, right? Is there a P? I think there's a P. I'm going to have to look that up. Yeah, asymptotes. Okay, I don't know. Let's look at this one, our letter O. So in this case, after we factored, we couldn't really cancel anything out with the 3x, but I think that we're going to run into a different situation here. So let's factor this. I can factor out an x. So I have x plus 3 in the numerator. And then I have an x plus 5 and x minus, or x squared plus 5x minus 6. So let's see what I get. X and x multiplies to get negative 6, adds to get positive 5. So one's going to be negative, one's going to be positive. Oh, we're not going to be able to factor out, are we? And minus 1, but we're going to do the same thing and find out what our asymptotes are. So x plus 6 equals 0, x minus 1 equals 0, and x equals negative 6 and positive 1. So our asymptotes are at negative 6, and you can kind of see here on our page that we have an asymptote here at negative 6, and we have an asymptote here at positive 1. There we go, which is our domain. So you can think about this, x doesn't, these are asymptotes, so our domain would be from negative infinity to that negative 5, right? And then negative 5 to positive 5, and then positive 5 to infinity. Okay, so that would be your domain if we were to write this out, meaning that x cannot equal those values, right? So our asymptotes are x equals negative 6 and x equals 1, but x cannot equal these values for our function. So our domain would be negative infinity to that negative 6, and then negative 6 to 1, and then 1 to positive infinity. So that would be our domain there, right? Or x cannot equal negative 6 or positive 1. All right, that's our note. So in class together today, we'll discuss M and I and G. Don't forget to put that equals 0, and you can check your answers as we go. I'll see you soon.